Okay, so in today's segment, we're going to talk about Newton's first law. Now, it's really important that you know Newton's three laws by name. For example, Newton's first law is the law of inertia. It's not just enough to know that one of Newton's three laws is the law of inertia. You need to know specifically that it is the first law. I have seen very specific questions on the MCAT that test your understanding of one of the three laws and then ask you a question that said, which law best explains this? And the three answer choices were Newton's first law, Newton's second law, and Newton's third law. So just goes to show, make sure you know them by name. So in this case, we're going to talk about Newton's first law, or the law of inertia. Now, inertia is essentially an object's ability to resist a change in its motion. In other words, objects at rest want to stay at rest. Objects in motion want to stay in motion. Now, a change in motion is literally an acceleration, right? Acceleration is a change in velocity over time. So if there is no change in motion or change in velocity, there is no acceleration. And what causes acceleration? Well, an acceleration is simply a force exerted on a mass. So anytime that there's a force on an object, as long as there is a net force that is not equal to zero, we will get an acceleration, and thus we will get a change in motion. Now, as you can see from this equation, that inertia is completely dependent on mass. So I like to think of mass as a measure of an object's inertia. So let me give you a few examples of some common misconceptions where students get confused on these subjects. So let's start off with a rock sitting on the side of the cliff. Does this rock have inertia? Of course it does. It has mass. Mass is a measure of an object's inertia, and thus it will be able to resist a change in its motion. Think about how hard it might be to push that rock off the cliff, to change its acceleration, right? Well, let me give you another one. Let's say that we've got a car. Let's say that this car is moving 60 miles an hour, and then suddenly we slow it all the way down to zero. Is this car going to have more inertia when it's going 60 miles an hour at top speed? Or is it going to have more inertia when it's almost at a stop, going maybe 5 miles an hour? You should have answered that it actually has the same amount of inertia both times. This can be confusing for a lot of students to understand. And the reason why is because what you're most likely thinking about is momentum and not inertia. Momentum, keep in mind, is mass times velocity. And this is unrelated to inertia. So yes, you're right that that object that is going a lot faster is going to have a lot more momentum, and it's going to take quite a bit more to stop it. But it doesn't mean that by exerting a certain force on it that we will accelerate it at a different rate. And keep in mind that when we're dealing with inertia, we are focused in on this acceleration, because that is a change in motion. And the rate at which the velocity changes is totally dependent on the mass. Notice that our velocity is not included in this equation of force over mass equals acceleration. That tells us that regardless of what our velocity is, our acceleration will not change if we exert a certain force on it. If we exert a certain force on an object going 60 miles an hour, it will accelerate at the same rate as an object going 5 miles an hour, because the mass does not change. And that's what we're dealing with when we're talking about inertia. Okay? So keep these two ideas separate. For my personal benefit, I like to think of mass as a measure of an object's inertia, and I like to think about velocity as being a measure of an object's momentum. That conceptual understanding can help you keep the differences between momentum and inertia straight on the MCAT.